Hello, everybody, and welcome to We Measure the World, a podcast produced by scientists for scientists.
So I noticed that there was this opportunity to do an inventory of all the landslide sites. And so, we visited many landslide sites, but we were lucky to have a really great aerial imagery data set for the whole island. And so I sent a message out to some students in our geology department at UPR-Mayagüez, and I said, I'm going to do this project. We're going to inventory all the landslides from Hurricane Maria. Please come to the university. We have power, we have water, and we have internet. And I had a group of about 10 students show up, and we got to work.
That's just a small taste of what we have in store for you today. We Measure the World explores interesting environmental research trends, how scientists are solving research issues, and what tools are helping them better understand measurements across the entire soil-plant atmosphere continuum.
Today's guest is Dr. Stephen Hughes. Stephen is a professor in the Department of Geology at the University of Puerto Rico-Mayagüez. He obtained his bachelor's in geology and earth science from the University of North Carolina at Chapel Hill and his PhD in geology from North Carolina State University. He teaches classes in structural geology, geomorphology, and field geology, and his research projects have focused mostly on tropical landslides and landscape evolution, with the funding of such organizations as the NSF, USGS, USDA, and NOAA. And today he's here to talk to us about all things landslides, including monitoring, forecasting, and susceptibility, impacts of mitigation, and more. So Stephen, thanks so much for being here.
Thank you, guys. I appreciate the invitation. It's a pleasure.
All right. With all of our guests, we like to start out getting to know them a little bit better. And so we'd love for you to tell us a little bit of your background, how you got into the sciences in general, and specifically, how did you end up in this specialty with landslide research?
Like you just read there, I went to UNC Chapel Hill for undergrad. I didn't know what I wanted to study, and I actually went down to the wire to declare my major. Finally picked geology, and I just ran with it. When I went to undergrad, I didn't know what grad school was. I thought, you go to college and that's it. And finally started, discovering these new avenues and opportunities. And I got lucky to go to grad school. I got lucky to sort of stumble into a PhD project. I didn't study landslides or hazards in grad school. I studied old Appalachian mountain tectonics, 450 million year old mints of plates and fragments of plates. Then I finished grad school. I applied to a bunch of jobs. I got one of them, and I moved to Puerto Rico, and I was surrounded by different types of hazards, flooding, landslides, earthquakes, almost everything you could think of, coastal erosion, tsunami potential, but almost everything except volcanic hazards. So yeah, I just, life gave me landslides, and I study landslides now.
Now that you're there in Puerto Rico, one of the main projects, and this is kind of going to be our main focus for today, and we're really interested to hear about this project and your work within it, is the SLIDES PR, which stands for Storm-Induced Landslide Impact Dynamics on Environment and Society in Puerto Rico. I'm sure you had a lot of fun, or somebody had a lot of fun coming up with that acronym. But can you tell us a little bit about the beginnings of what this project is and how it came about?
All right. Yeah. So I moved to Puerto Rico in 2014, 10 years ago now. And it's a great place to think about geology, to do all kinds of science. Very diverse geology, diverse soils, different little microclimates. And it's a pretty small island. The sort of colloquial explanation is 100 miles wide by 35 miles north to south. And a couple of years after I moved here, we had a big Hurricane Maria in 2017.
Mm-hmm.
It was sort of a watershed moment in many of our lives for many different reasons. Some people moved away from Puerto Rico, some people major changes in their lives, and, everything was sort of reset in the worst way possible. No power, no water, no communications or anything for quite some time. So the hurricane came through, and in the months after, saw what was happening around me, and it was really hard to get around that period of time, especially in the interior part of the island, which is the most mountainous. So I noticed that there was this opportunity to to do an inventory of all the landslide sites. And so, we visited many landslide sites, but we were lucky to have a really great aerial imagery data set for the whole island. And so I sent a message out to some students in our geology department at UPR-Mayagüez, and I said, I'm going to do this project. We're going to inventory all the landslides from Hurricane Maria. Please come to the university. We have power, we have water, and we have internet. And I had a group of about 10 students show up, and we got to work. And wow. And so that was sort of the beginning of what has morphed into a bigger project, long-term project. And so a lot of steps along the way. But that was how we got started. So that Hurricane Maria in 2017. And so we ended up with an inventory of over 70,000 landslide headscarp sites that was published. And then we went on to do other things. So I've had a lot of great undergrad research students and a lot of great master's students along the way. And so I guess if we started in 2017, we're 7 or 8 years in now.
How many landslides were triggered by that hurricane?
Yeah, so that's the number that we came up with was that 70,000.
Wow.
Yeah, most of the landslides that we see from Hurricane Maria or most landslides in Puerto Rico are shallow soil movements. Mm-hmm. A lot of times they transition into debris flows. Mm-hmm. The case with Hurricane Maria was special because there was another hurricane that had sort of sideswiped Puerto Rico 2 weeks before. Mm-hmm. And so that sort of set the scene for many landslides mm-hmm. across the island. And we had this aerial imagery data set, and that made it possible to actually, manually, one by one, go review each site, have that data set.
So at the beginning, at that stage, I mean, what were the goals? Was it simply just to try to take an inventory? Was there anything beyond that as to try to figure out, I guess to get into any more details than that, or was that kind of basically it right there at that beginning point?
That was the initial goal. I always knew once we had the inventory, we'd be able to build off of that, especially, for susceptibility map purposes. And that's what we did. So we took this inventory and, when you want to build an empirical model or an empirical susceptibility map, having ground truth data is like gold, mm-hmm. Right? Mm-hmm. And so we had all these headscarp points. And so we were able to use that data set and really carefully look at different factors at each site. Of course, the slope, the soil type, the geology, the curvature, the land use, how far away from road cuts or roadways, how far away from fluvial channels, and a lot of other metrics that we were able to calculate for this large data set of headscarp points. And so yeah, the idea was that, let's do this inventory and let's go from there. Hurricane Maria was in 2017 and we didn't publish the inventory until 2019. Mm-hmm. So it was a process. It was very difficult. And, if I didn't have that great group of students at the onset there, we wouldn't have been able to proceed with things like the susceptibility maps that we created for the whole island, or our monitoring network that we have, or our new office that we're hopefully going to open pretty soon on campus.
I mean, you mentioned 70,000 landslides that you inventoried. Were you going through and categorizing and getting measurements on each and every one of them, or did you go into kind of a sampling process after that?
Well, what's I guess I'll say convenient is that before Hurricane Maria, about 1 year before Hurricane Maria, we had a complete LiDAR-based survey across the whole island. So we had really good high-resolution topographic data mm-hmm. of the before. And then after the event, there was another data set of LiDAR collected across the whole island. So we had this snapshot of before and after. And so once we used the aerial imagery to determine to build our inventory, we're able to look at each site and determine especially area and volume metrics. Mm-hmm. And so the relationship between the area and the volume is important, the scaling. Obviously, if landslides are deeper, they'll have a a larger volume for any given area, or if they're more shallow, they have a smaller volume. And so we're able to look at that area volume scaling for specific conditions, specific soil types, specific slope angles. And then with that information, we can look at, for example, the amount of sediment that we think was mobilized in a certain watershed. And nice to think about this sort of on watershed scale, especially because many of our watersheds we have reservoirs, to store fresh water. And so those reservoirs caught a lot of this landslide sediment. And so we're able to measure in the headwaters where, the amount of sediment we think was mobilized. And then we've partnered that with bathymetric surveys in some of our reservoirs and try to compare and contrast where we think is, coming out of the hillside and what's getting deposited at the reservoir, which is the sink for most of this sediment.
With all this now, are you setting up remote sensing stations now? Is that kind of like the next step of how this project has evolved?
Right. So we do have a network of monitoring stations. So we've chosen sites across the island where we think landslide susceptibility is pretty high. We install monitoring stations across these areas. So right now we have 18 stations, though that network is collaborative with the Geological Survey, United States Geological Survey Landslide Hazard Group. And so that monitoring network started out with 2 stations in 2018. And then we've been able to really ramp up in the past 2 or 3 years. And right now we have 18 stations. And, we use those stations as sort of representative locations across the island. So we don't measure the potential for landsliding in any one specific place. What we want to measure are the soil moisture conditions in a place that we think is representative of a smaller region or a little bit bigger region, and then use those metrics and then use new landslides that we can observe and we can see at the same time that we had our monitoring station, and then use that combination of information and data to try to get metrics or thresholds to forecast when more landslides might be likely or potential in the future.
What are you guys measuring at these stations, Stephen?
Right. So we measure rainfall. We measure volumetric water content, we measure soil suction, and we measure groundwater pressure. And so all of our measurements, other than the rainfall, of course, are in the soil, right? So we choose a site, we dig to the base of the soil, which is usually on these steep hill slopes, which have suffered erosion during human times and even before. We have about a meter of soil on a pretty steep slope in general. And so we install different levels of sensors until we get to the base of the soil.
And that base is when you're hitting the bedrock. Is that what you're considering that?
I call it bedrock. A person from a non-tropical area might not call it bedrock, but it's something that is it's something that's less like soil and a little more like saprolite,
right,
regolith type thing. So, and we've seen a lot that this boundary between, legitimate soil and regolith or saprolite below is quite often the surface where we see the movement.
Right. That makes sense. Yeah.
So along these lines, I mean, there's critical measurements that you're finding. What have you been finding when it comes to the triggering of these landslides? Have any of these findings been surprising in any way?
Right. So, years ago, there was this idea that tropical place like Puerto Rico, that the soils were always saturated and you didn't need to really think about antecedent soil conditions in terms of landsliding. But it turns out, like I mentioned before, we got quite a diverse mixture of soils. We have very clay-rich soils, we have sandy soils, colluvial soils, and they all act different. And so, we do have some monitoring sites where the soils are, almost completely saturated all year. And then we have some that are much less saturated during the year, especially during our dry season. So I call them more flashy. They fill up and they drain out pretty quick. And so to answer your question, one key observation that we have is how are these soils reacting to different amounts of precipitation across the island, which is small, remember? But even in, close proximity to each other, some of these stations some of these soils are reacting and behaving much differently. So that's one thing. And another thing is that we can see pretty well how much rain will saturate just sort of the top bit of soil. And so, we could have a 2-inch rain event and maybe the base of the soil isn't affected at all. So it just depends each area how the soil is reacting, is behaving. And, this week actually, now that we're into May, we're sort of in our mini rainy season. And so we've had sort of these successive days, 1 or 2 or even more inches per day. And we've been able to see, a 1-inch rain event after, a week of 2-inch rain events, may increase the soil saturation more than one of the initial 2-inch rain events. So just sort of this dynamic between the soil and the precipitation and things like that.
I know I was looking at one of the publications that you were involved in that was looking at slope and the relationship between the incline of the slope and the susceptibility or the triggering of the landslides. And if I remember right, and you can correct me, is that some of what you were seeing was that a lot of there were more landslides associated with moderate slopes than the steeper ones. Is that correct? Am I understanding that? And that was kind of an interesting finding there.
I think you got it pretty good. So what we actually found out is that if the slope is extremely steep, we're talking 80 degrees or 90 degrees, there's likely no soil there. It's likely, if anything's going to happen, it's going to be a rock fall. So the mechanism when you get that steep, if the slope can't hold a soil, then it's going to be a totally different movement of rocks. And so we have different areas across the island, especially in our north coast. We have karst, limestone dissolved away, and so we have caves and sinkholes, and the opposite of sinkholes, which we call mogotes. And so they have really steep sides, these features, and so there's almost no soil on these extremely steep slopes. And so that's why when we did that analysis, we found that the steeper slopes, they do fail, but the soil failures are much, much more common when there actually is soil, right? So I think that's what we were trying to get at whenever we wrote that, if that makes sense.
Yeah.
Yep.
Yeah, definitely.
Yep. No, I mean, you kind of need soil there for there to be soil-driven failures.
Yeah.
Right. And that's sort of one thing with where we install our stations. Where we install them, it's quite steep terrain, but you get past a certain angle, and there's just not much soil left. And so if there's no soil, I can't install anything.
That's right.
So Stephen, you said that, when you guys were doing that really detailed analysis of 70,000 landslides, you were looking at other factors like land use and proximity to roadways and things like that. Were there other things that stood out beyond just the slopes that were more likely to result in landslides?
Right. Actually, so I think our strongest correlation was the soil map unit, but also, really important, like you mentioned, is the proximity to roads. And so I think we did the math that if Puerto Rico was an independent jurisdiction, it would be the 9th highest road density in all of the world. And so that includes places like Monaco and Vatican City that are like, just city-states essentially.
Right.
And so we have a lot of roads here. We have even more roads than we used in that analysis. We have a history of intense agriculture across the island. We have a dense population of humans here. And so there's roads everywhere, and there's also abandoned roads that, are now covered in jungle, but as you move across the landscape, through the bush, you can realize, hey, I'm on an old road cut, and maybe there might be 50-year-old trees or 75-year-old trees as you're walking, but you can see you're on a road cut. And so that legacy of improvised roads, I think is a good way to say it. Maybe first they were for ox, or maybe later carts or something like that. Those improvised roads are essentially like a spider web across our mountainous area. And so these are places where they farmed coffee, citrus, tobacco, things like that. Where they farmed sugar is more down in the coastal areas, but up in the mountains, those were the crops that were the main focus. And so the way we made that model is we took all these analysis of these different factors, and we smushed them all together, and then we came out with a map in the end where we have every 5 meters on the island classified as either low, medium, or high, or really, really high physical susceptibility.
Yeah, that's amazing. I took a look at that map of yours. It's the granularity is incredible, and like you said, being able to have GIS, LiDAR, now your inventory of all of that. I mean, I'm a sucker for cool maps and charts. Like I've got the Esri magazine comes to my house, and my wife and kids are like, awesome. What are you doing? I'm like, I like the maps, I like the charts. But again, that granularity, which then we'll be able to, and we'll get into this here in a little bit, but then we'll be able to inform future research. We'll be able to inform, prevention, mitigation efforts, all those kinds of things. I think one of the things too that you mentioned about there in the central mountainous areas with that spider web of roads, I would assume that's where my assumption would be that's where the greatest impact would be when it comes to these landslides. Is that correct? And the places of greatest vulnerability. I guess, can you go into a little bit more detail about, some of the impacts of these landslides that are happening all over Puerto Rico?
Right. Yeah. So you hit the nail on the head. The central mountainous area. So I don't know, I guess sort of roughly 2/3 or 3/4 of the island is pretty rugged mountain. And, we live on an island where our highest point is a little over 4,000 feet in elevation above sea level, but it's within about 20 miles of sea level. And so there's a steep gradient to get up to these higher areas. And so, as you might imagine, those central areas are more rural. There are less people. There are also less services. There are less hospitals. There are less of everything, less access. And there are also the areas that it rains the most because of the orographic effect. And so there's a lot of other factors. I mean, we could think about mean annual income and poverty rates. And so if you compare Puerto Rico to the rest of the United States, I think Mississippi is number 50 on a lot of lists. And so we're lower than Mississippi. And so there are challenges in a lot of different ways. There are sort of improvised constructions that are not permitted, and things like this. And so whenever these landslides happen in the mountainous areas, they do hit houses or water infrastructure or things like that. But probably the most impactful situation is whenever they take out roads. Either the road itself collapses or the landslide falls down and covers the road, and it cuts off access to entire communities. And sometimes the community might be 4 houses, or sometimes it might be hundreds of houses. And so it complicates everything. Oftentimes when there are landslides in the mountains, there are floods somewhere else, right? And so all of the folks who are responders are essentially pulled in every different direction. So a lot of the people that live in these vulnerable rural communities are older folks. The population dynamics of Puerto Rico are skewed towards older folks, because a lot of the younger people have moved away. So all these sort of layers of complications get wrapped in, and then landslides are just one way to really disturb an already sort of fragile way of life.
Along with that, how have you seen, over the time that you've been there, how have you seen that risk of landslides changing, I guess, over the past 10 to 15 years or so, with impacts of climate change, intensification of storms, all those kinds of things?
Right. So yeah, I mean, I've lived here for 10 years, so I got a decent perspective, I think. And so it's sort of, there are changes with climate change. If you expect, the Atlantic hurricane season to have more named hurricanes or more, significant tropical storms, then, well, there's more chance that one of them's gonna hit us.
Right.
In the grand scheme of things, Puerto Rico's a pretty small target, but more storms means more potential that one of them hits us. But it's not just with these tropical storms and hurricanes coming through. We're in the first week of May right now, and there have been landslides scattered all around the island in the past week or so. It's because we have this weather system that's called a trough. It's not a tropical cyclone or anything like that, but we just sort of get stuck in a really rainy week. And so we were actually in drought, maybe a month or so ago. And as the mini rainy season has kicked in, we've seen landslides. And so they've blocked roads, they've, hit power poles and stuff like that. And so they're not these big, deep bedrock landslides that, move mountains, literally. But they're the type of small superficial landslides that if you are unlucky enough, they can affect you in a really unfortunate way.
How then are you taking what you've been learning? You mentioned about your susceptibility map. How's that being communicated to the public? How are you interacting and cooperating with government agencies in order to inform the public? How's that moving along there in Puerto Rico?
Right. Yeah. So one thing I like about our map is that it's published in English, but it's also prepared fully in Spanish as well.
Yeah, I noticed that.
We have a landslide susceptibility or a landslide guide for residents of Puerto Rico that was prepared only in Spanish and then later translated to English. We have initiatives to get involved with, municipality scale emergency managers. So in Puerto Rico, it's a small place. It's about the size of Connecticut. So if that's a good reference, there are 78 municipalities. So that's sort of our county equivalent. But so there's a lot of different moving parts. We work with a local earth science museum called the Eco Exploratorio. So we give presentations. We have another initiative called Landslide Ready, which is our version of something that's called Tsunami Ready or Storm Ready. I don't know if you've heard of that, but we're pushing that idea, and we have a pilot municipality partner on that. So it's essentially a way for us to have a line of communication with emergency managers, not necessarily in the time of the emergency, but maybe just to orient whoever's working at that scale about the maps, the guides that we have, the data from our stations, if it's useful for them. So yeah, and we have agreements with different groups like our Natural Resources Agency. We have an agreement with them for a few of our stations are on their state lands. We have an agreement with Conservancy Group. So we try to talk to anyone who will listen to us, so that they can take our information. We also have a really good relationship with some of the TV meteorologist folks here in Puerto Rico. So they quite often will share data from our monitoring stations, or they will share information from our guide for residents. So talking about signals that you can maybe expect a landslide. So we're really fortunate to have a good sort of ecosystem of collaborators, some more formal, some more informal. We also work with a lot of community leaders in different sort of points around the island, usually connected to where we have our monitoring stations. So like I mentioned before we started here, it's a work in progress, and we're trying to build this landslide hazard office in our university here in Mayagüez in the west part of Puerto Rico. And so we're having the opportunity to grow, and we're trying to continue that growth and hopefully do some useful stuff for folks in Puerto Rico.
Mm-hmm.
That's awesome. Yeah, you mentioned earlier that you guys will be opening the new office on campus soon. So that office is purely focused on landslides?
That's right. That office will be called the Puerto Rico Landslide Hazard Mitigation Office. It's been a process, but we'll have a devoted space, and we'll have, a physical place that's dedicated, to the monitoring, to the education efforts, and all this stuff on campus. And so we also have on campus an office called the Puerto Rico Seismic Network. And so they monitor, earthquakes, and they're very involved with the tsunami education activities. And so we're sort of modeling and sort of following the script that the Seismic Network did. We're just about 20 or 30 years behind.
Well, little room to catch up, but that's all right.
Get there. Right.
Yeah.
So what are some of the primary, impact mitigation efforts that are going on there in Puerto Rico currently, and what does the future of that look like?
Yeah, it's tough. I mean, so essentially we know landslides are going to happen, and in most cases there's not a good way to prevent them.
Right.
So I think our best goal is just to communicate susceptibility, to communicate risk, to have our monitoring station. So we have a prototype of a forecast system. So we incorporate data from our monitoring stations and data from precipitation models. And then the idea is we do have a 1 day, but then also develop a 2 day, a 3 day outlook for when and where are landslides likely across the island. And so that's also sort of a work in progress, but we can actually see the light at the end of the tunnel there. And so it would be that we create this product, we make it available, and then partners in either the weather service or emergency managers, if they want to use that information to make announcements or to make plans, then I think that would be great. And so have to be sort of very procedural and careful on the way that gets carried out, and sort of how do people interpret this, because you can imagine a forecast for landslides might be tricky, the way to communicate that information.
Yeah.
It's not like a flood. A flood is going to be in the floodplain,
Right.
and so there's a very discrete zone, and that's it. But landslides are more distributed. They're more spread out than perhaps a flood or even a tsunami, right? The tsunami map is, you've got this sort of area around the coast, and you just get out of that area, right? But a landslide map or landslide situation is much different. It's not one specific spot that you have to avoid. It's more complicated, I think.
Yeah, I can imagine that.
With your work there in Puerto Rico, and now, granted, you are specifically within a tropical environment, but we were wondering about what are you doing now, and what have you been doing that then could be applied elsewhere? Is this something is there a potential here for the work that you're doing with the Slides PR project that then could be applied, elsewhere in tropical areas throughout the world, or other places? Is this something that could be applied back in North Carolina with issues, of potential landslides in, Appalachias?
What we're doing with our monitoring stations is not super complicated. It just sort of involves a plan and what you want to get out of it. And so the same method could be applied anywhere, really. It depends what that study area would be interested in. And so there's an international group of folks called LandAware. It's the international sort of focus group on landslide early warning systems. And so I've learned over the past few years that there are many different types of landslide early warning systems globally. Some are very simple and they work great. Some are more complicated and they, maybe work just as good or maybe not as good.
Yeah.
So I think each place is specific. And so if you're worried about rainfall-induced shallow soil landslides, then the approach that we're using here is is a great way to go. So, but if you're worried about one large bedrock landslide, then you'd need a different approach. You need to be thinking about very site-specific measurements and sensoring. So I think it depends what your end goal is, because, you know, we use this term landslides, and it's a huge umbrella term that a lot of other things fit underneath. So I think, yes, you could use the same approach that we have going here, but it just it depends the place, and it depends what your ultimate goal would be.
Yeah, I think something that's really interesting about your approach versus some that I've heard in with other researchers that I've communicated with is, you know, you're not trying to monitor a specific spot to capture data from a landslide in that spot. You're just trying to collect data to better inform some of the conditions in the area and what's going on and leading to those landslides. And I think that's a much more easier to apply approach, because it's really hard to predict exactly where a landslide's going to occur. And and also, if your station's in a spot where a landslide does occur, when that does occur, that station's pretty much done. And so
that's right.
It would go out in a blaze of glory.
It
would. We'd hopefully have some really good data on whatever happened. But, you know, we haven't lost a station yet. We're very fortunate. None of ours have been swept away in a landslide. None of ours have been, you know, vandalized or damaged in any way. So so far so good.
We live here in the Palouse in Eastern Washington. The environment here is really different from that of Puerto Rico. What are some of the challenges that you guys have with deploying and doing field work out there?
I think, yeah, you can imagine it. Mud. There's a lot of mud. You know, our last station we installed, I guess about a month ago now. And, you know, while we were, you know, connecting all the wires and setting the data logger, it just downpoured on us.
No.
So, but, you know, it's not that bad, especially, you know, I haven't spent too much time in Eastern Washington. I think that's the scab land. Right?
Yeah, we're just beyond that. So this is the area that formed thanks to the scab lands, where all the silt was deposited by wind. So
I imagine that access to private property and things like that are sort of tricky where you guys are. But here in Puerto Rico, you know, the access and, you know, just the nature of the folks who own the land, they're very welcoming. And so we've always had a really easy time. And, you know, we say, you know, we're from the university and we're interested in landslides, and people just, they're very happy to collaborate with us and give us access to their, you know, to the lands that they have. And usually the places where we want to put monitoring equipment, they're trying to avoid. They're so steep, you know. So that works out great. So the people, you know, the weather can be an issue, but also can't complain.
Yeah.
Okay.
No, that's awesome.
I guess in our last few minutes here, if you could put on your prognosticator hat or whatever, what does the future look like for landslide research there in Puerto Rico, elsewhere? What are you hoping to accomplish? What would you love to have if you had, you know, unlimited funds, type of thing, you know, carte blanche and all that? What does that look like for you?
Right. Yeah. I'd love to have unlimited funds and unlimited time.
Right.
That would be also great. We're trying to grow this landslide office. And so sometimes I'm not very patient. I want to do things quick and, you know, but I think the sort of slow progress that we've made has been helpful to sort of work out some of the kinks with things, to figure out, you know, better ways to, you know, to prepare, you know, forecasts or things like that. So I think in the future, what I'd like is I'd like to have more people power in Puerto Rico. There is no geological survey office. I think we're feeling sort of a void, which I'm happy to do. And, you know, we're at the state institution, which is, I think, good. And I think, like I've mentioned, we have good partnerships and good partners with many different groups. And, you know, just to sort of expand our people power, also keep pushing this idea of landslide ready, to work more directly with municipality, especially emergency managers and other municipality level people. They're really the ones where the rubber meets the road. And so, yeah, I'd say those two things, just people power and more the landslide ready effort. And I think I think we're doing an okay job, and this is sort of going to be the rest of my career. I'm seeing that, and I'm excited to take it as far as we can go.
That's awesome.
Yeah.
And I guess everybody needs to get LiDAR surveys of their research areas, right?
Yeah. I think, every year there's more and more and more. It's absolutely incredible the amount of LiDAR coverage in many different places around the world.
Yeah. I've been following, along with archaeology. There's been a lot of really cool stuff with LiDAR, especially there in Latin America, Central America, and being able to uncover a lot of really cool things.
Yeah, LiDAR is a cool technology.
The only problem with LiDAR is that you want more LiDAR, more and more.
That's right. Our 1 meter resolution is not good enough, right?
And more surveys, more.
We need it every year.
That's right.
We need to see the.
That's
change
right. We need to see the
year.
change. Yep.
Yeah.
All right. Anything else you'd like to share before we go?
I think that's about it. So if anyone's interested that's listening, they can look up our webpage. Our webpage is derrumbe.net. So derrumbe is the word for one of the words for landslide in Spanish. It's DERRUMBE. So derrumbe.net, and you'll be able to see data from our monitoring station or our landslide guide or our susceptibility maps, how to contact us or anything like that. So that's good with me. I appreciate it very much. Again, thank you both. Appreciate it.
Yeah, no problem. Any final questions, Leo?
No, I think we've about covered it. I have one that's not really related to this, and I'm just kind of curious. You in one of your publications, and I'm asking this because we teach environmental biophysics at the university here at WSU, and your one of your publications is the impact of lab style, course times, and teacher gender on course evaluations. And I'm just kind of curious as what prompted that, and if there were any interesting findings from that.
Well, I'd have to revisit that. I was not the first author. I think my grad school colleague, Catherine Riker, was the lead on that. And so we were in grad school at NC State, and we were all teaching intro labs for geology.
Yeah.
So I'll have to revisit. But I remember that she had some very interesting results on those specific things related to the labs. I mean, and I loved teaching the labs because that's sort of where you got to really try to convert people from other majors into geology. And so I have to revisit. Let me get back to you.
No, that's great. I'll have to look into that as well. I think that's super cool. I actually teach the lab for environmental biophysics. So I agree. It's really fun to have that interaction with students. And no, I think that's super interesting.
Yeah. How has it been with you with balancing, research and teaching? I don't know if we get to ask our guests too much of that. We have a lot of guests in academia who have to do both or are trying to do both. How has that been working for you?
Right. It depends how you want to go about things. I mean, so in my institution, if I wanted to be just full-time teaching, they'd give me, X number of classes per semester, and I teach them, and that'd be it. And so once I move into the researcher sphere, I need to sort of think differently. Almost all of our funding for research at my institution is external funding. There is some support within the institution, but essentially, if you want to do research, you're going to have to write proposals. You're going to have to get those proposals funded, and go about it that way. And so it's a lot different than teaching. Of course, there's the actual research, but then there's a lot of management and budgeting and forms and documents and all this kind of stuff. So I love it. I have a great time doing it. I especially love, supporting students, undergrad research students and graduate research students, and, sending them to conferences and working in labs in the continent and stuff like that. So that's how that's been. So the way it works out is if you get external funds, then you can sort of move away a little bit from teaching, but I still teach one class per semester, and I also teach our summer field course each year as well.
Awesome.
All right. Well, I think our time is up for today. Thanks again, Stephen, for being with us. We really appreciate you taking the time to talk with us. It's It's been a fascinating conversation.
Of course, my pleasure. I hope we cross paths again.
And if you in the audience have any questions about this topic or want to hear more, feel free to contact us at metergroup.com or reach out to us on Twitter at meter_ENV. And you can also view the full transcript from today in the podcast description. That's all for now. Stay safe, and we'll catch you next time on We Measure the World.